Google Compute Engine. Our journey through the compute products here in Google Cloud Platform is going to begin with Google Compute Engine, or GCE for short. This is GCP's infrastructure as a service offering that allows us to spin up virtual machines or even entire networks of virtual machines where the hardware layer is fully managed by Google and we are responsible for the software layer. So let's jump right in and take a look at what Google Compute Engine is all about. Compute Engine gives us the tools and resources to build infrastructures tailored to our workloads. So maybe you need something simple, just a single server to host your web application. Maybe you need something a little more complex, a cluster of machines to host your enterprise application. Or maybe, just maybe, you're building the next Skynet and you need a freaking army of machines that span the globe with subnets and regions all load balanced. And now I'm getting a little crazy, but you see where I'm going. It's an incredibly flexible product. So there's really something for everyone. Now, one area where Compute Engine is absolutely crushing the competition is pricing. There's a lot of built-in features that you just automatically get. You don't have to do anything. There's no commitment. They just happen. One of them is sub-hour billing. So you're paying in minute-level increments with a 10-minute minimum charge. So you're literally only paying for what you use, unlike other clouds where they generally charge by the hour. Another one that I don't have on here is sustained usage discounts. They automatically give you discounted prices the more you use it. So again, it just happens. Those long-running workloads are going to cost cheaper the more that they run. Another really cool and relatively new feature here is preemptible instances. These are just like regular virtual machines, except they're a lot cheaper, up to 70% cheaper. And they're short-lived. They live up to a maximum of 24 hours before they're terminated. So for those short-lived or fault-tolerant workloads, they're perfect. And it's really a win-win for everybody, right? It's a win-win for Google because they can make use of those idle resources, and it's a win-win for us because we get them at an incredible discounted rate. Some other notable features here. Robust networking. We've got resources inside of Compute Engine that allows us to create firewalls. We can create routes. We can do subnets and protocol forwarding and VPN, just to name a few. And don't forget that we're running on top of Google's private global high-performance fiber network. Google has no equal in this space, so the speed and performance is truly unmatched. GCE also supports instance metadata and startup scripts, so our virtual machines will expose their information via metadata, things like its hostname, its IP address, all that information about the machine, and startup scripts are scripts that fire up when the machine starts. These two things combined really give us a way to create some dynamic machines. They can spin up and configure themselves on the fly, and I just keep thinking to myself there, Skynet, the next step, it's almost here. It's only a matter of time before these machines bust out of Google's data centers and start walking among us. Watch out. We also have a wide range of machine types to choose from. Now, this bullet actually got very interesting here recently, and I'll tell you why shortly. But a machine type is what powers our virtual machines. It's the physical specifications of our machines in the form of CPU and memory, virtual CPUs and memory. And most clouds, and as was the case with Compute Engine until recently, you had to choose a specific class, right? Small, medium, large, extra large, essentially, which meant you were either paying too much or you had too little in the way of resources. There was no way to perfectly balance your price with performance. Well, recently, very recently, custom machine types became generally available, meaning we can choose whatever we want in the way of CPUs and memory, and we can get that perfect balance. We can really optimize our machines for the workload and pay exactly what we need to for performance. We also have some great load balancing features here. HTTP for cross-region global load balancing, and network for TCP/UDP load balancing within a region. Google Cloud Monitoring is a really neat tool that allows us to create uptime checks so we can monitor uptime, we can create alerting policies and get notified when something goes wrong, and we can even create dashboards off a lot of the metrics that are generated from our Compute Engine infrastructure. We also have the ability to take snapshots of our persistent disks. So very, very simple to back up our data or copy our data or migrate our data between machines. We also have some advanced APIs out here that allow us to do some pretty cool stuff. Group management. This is actually known as instance groups, and it allows us to create pools of virtual machines based on a template. And then we also have the autoscaler, which allows us to automatically scale machines inside of an instance group based on traffic and based on specific metrics, right? So we can do this based on CPU, or we can do it from metrics from cloud monitoring. But essentially, this allows us to scale up when traffic increases and scale down when traffic lowers. So we can, again, get the best in terms of price and performance and only pay for the resources we need at any given time. Let's go over Compute Engine's resources. These are the components you'll be using to build virtual machines and cloud-based networks. So a virtual machine in Compute Engine is known as an instance. When we spin up an instance, we're going to choose where that instance lives, what zone it lives in, as well as the machine type, which is, again, the physical specs of the machine, the CPU and memory. Then we're going to attach some persistent disks to it. Persistent disks are block storage. They come in the form of standard and SSD. These are network attached storage, as well as local SSD, which is directly attached storage, which you'll use for those very intensive workloads. You can get some pretty insane IOPS here off local SSDs. So we can create many persistent disks and attach them to our instance, but one of those disks must be a boot disk, otherwise known as a root persistent disk. And we're going to create those from what are known as images. An image contains everything our machine needs to fire up. It's going to contain an operating system, a bootloader, and a file system. And we've got images that span all the different platforms out there, Linux, Unix, and Windows. And you can even bring your own image. So if there's an operating system that isn't in Compute Engine, you can certainly bring your own as long as you follow a set of rules when building that image. And you can also create your own custom images. So if you build a virtual machine and you get it to the state where you want it, you've customized the OS, you've customized the software on it, you can then take your own custom image and use that to spin up more machines. Very cool. As I mentioned earlier, we can snapshot our non-root persistent disks, our data disks. This is useful. It allows us to take a snapshot and then create new disks from that snapshot. So useful for backing up data, recreating a persistent disk that might have been lost, or even just copying data and migrating it across regions. We also have a network resource, so of course we can create many virtual machines that can talk to each other. We have firewall rules, so we can dictate traffic coming in and out of our network. And we can also set up forwarding rules, so we can balance traffic across pools of virtual machines. So these are the primary resources you'll be working with when building instances and networks. Let me just take you up to the developers console real quick to show you where this stuff is. So if we hit the drop down here, here's Compute Engine. I'm just going to pin that down so it's up here for quick access going forward. And I'm also going to pin down networking. All right, let's click on Compute Engine here and go right into it. Now on the left nav, we have all of those resources that we can create. Many of these we talked about here. Here's VM instances. So this is will give us a good list of all of our instances. We still have one in here from a previous lab where we created our CP100-Labs instance. We also have instance groups. This is where we'll manage our pools of virtual machines. Instance templates, where you'll create templates to create those pools of virtual machines. We have disks here, and you can see these are resources that you can create independently and then attach to machines. Here's our one disk that we have currently attached as it is in use by this machine right here. Here's where we'll manage our snapshots. Here's a big list of all the currently supported images that span everything from, again, Linux, Unix, and even Windows Server down there, 2008, 2012. Metadata. This is actually project-wide metadata. So each instance exposes its own metadata, but you can also create project-wide metadata, which is available to all of the instances here in your project. Health checks is used with load balancing. Here's a list of all the zones and their current status, operations that you've performed, quotas, and some settings. If we head over to networking, this is where we'll create networks. So we can create many networks inside of here. Here's external IP addresses. We'll actually create one of these in our lab here immediately following this nugget. Here's where you can manage your firewall rules. Here's the default firewall rules in place. You can set up routes. Here's our network load balancing, HTTP load balancing, Cloud DNS, as well as VPN. So these are all the options here inside of the web UI, and we'll look at more of these when we talk about the G-Cloud utility. Moving on, let's talk about Compute Engine billing. So when it comes to billing, for instances, you are only charged while they are running, and they can be switched off, and that's why I'll remind you at the end of every lab to turn them off, because you won't get charged for them if they're not running. Disk, you are charged for the allocated amount, not the amount in use. So if you allocate a 100 gigabyte disk and you're only using, say, 10% of it, you're charged for the entire 100 gigabyte. Now, as far as billing for network operations, the answer is it depends. Generally speaking, ingress, inbound traffic, no charge. Outbound traffic, egress as we call that, the answer is it's going to depend. To the same zone, generally no charge. To Google Cloud Platform or other Google products, no charge. But between zones in the same region or even between regions within a geographical location, you're going to get charged. And the rates are going to vary depending on where you are in the world. But I would definitely advise checking out this link down here. It breaks down pricing across compute, storage, and network very well. I would also advise you to check out the pricing calculator. This is a wonderful tool, very easy to use. You can use it to create estimates and really get a good idea of what your workloads are going to cost you. And it goes above and beyond just Compute Engine. You can use this for all of the products here in Google Cloud Platform. So certainly check out that link. It's very well done. Let's talk about our good old friend G-Cloud Compute. So this is our command line utility found in the Cloud SDK for managing GCE from the command line. It's an excellent utility, very easy to learn and pick up. If you install the Cloud SDK locally, you can manage those GCE resources from your local machine, or again, you can use Cloud Shell inside of the developer's console, which ensures that the SDK is always on the latest version. You don't have to manage anything locally, and it's just a wonderful, wonderful tool. But gCloud Compute, very easy to use. So gCloud Compute followed by what's known as our command group, followed by a command, and then we'll have flags for that specific command. So running a gCloud Compute-H will get us a list of all of those command groups. So here are all the resources we can work with. Then running a gCloud Compute command group-H, I did instances in this case, will give us all the operations we can perform against that resource. Now, in fact, you want to see something cool? This is a great way to learn this stuff. Follow along with me here. Head into the developer's console, fire up Cloud Shell, and that'll just take a minute to spin up. I'll just bring this so it's most of my screen here. And when it's done, run a gCloud Compute and pass in the H flag, just like so. gCloud Compute/H. This will show us all of our command groups. So all of the resources that we can work with at the top level, right? We can work with addresses, disks, images, instances, snapshots, all kinds of great stuff. Those are all the resources we can work with. Now, recall your last command and say we wanted to see the kinds of operations we could perform against instances. Let's throw in instances in there. So it's gCloud Compute instances, pass in the H flag, and there it is. We can create an instance, delete an instance, start and stop an instance, reset an instance, move an instance between zones, all kinds of great stuff. Attach a disk, detach a disk. Cool, right? Now do this one. Let's say we wanted to create an instance. Well, we want to know the kind of arguments we can pass in to the create command. gCloud Compute instances create, pass in that H flag, and we'll get help. And here are all of the arguments we can pass in when we create an instance. Check that out. We've got some flags here. Boot disk auto delete. So if we delete an instance, do we want the boot disk to go away, or do we want it to stick around so we can manage that manually? We can choose our custom CPU and custom memory. That's for your custom machine type. Or you can choose a predefined machine type. We can specify our image that's going to go on the boot disk. We can specify metadata. We can specify the network it belongs to, the subnet, the zone. Here we can even make it preemptible if we pass in the preemptible flag. So just a great way to learn this stuff is to build your commands and pass in that H flag so you can get a nice quick overview of what they support. Now, what about accessing your instances? Incredibly easy to do these days. For Linux and Unix environments, you're going to access it using a secure shell, SSH. And we can do that a number of ways. We can do it from the Cloud SDK. We can do a gCloud Compute SSH, pass in the instance name, and boom, that'll get us right onto that instance. You can actually do that from Cloud Shell, which I'll show you when we get into our lab. You can also use standard SSH. So you can generate your own keys from your own environments, upload them to your Compute Engine instances, and SSH from standard tools. Or you can do it from the developer console right in your browser. Very simple to do. We actually did that in a previous nugget. Your instances have a little drop down to the right of them. Drop that down, choose SSH from your browser. It opens up a browser window, and you're in. Here's what that looks like, by the way, from your browser. And by the way, here's SSH from Cloud Shell. Now, if you have Windows Server instances out there, then you'll RDP right into those instances. You can download the RDP file right from the instance inside of Compute Engine onto your local machine and RDP right into it. And they even come with the Google Cloud SDK pre-installed on them, ready to go. More on all of this stuff and working with Compute Engine resources in our Getting Started with Compute Engine lab. In the CBT Nugget, we took a look at Google Compute Engine, the infrastructure as a service offering in Google Cloud Platform that allows us to spin up virtual machines and networks in the cloud. I hope this has been informative for you, and I'd like to thank you for viewing.